In lecture 3, I am going to discuss about remaining problems of Green's theorem. Next problem is find the area bounded by curve equation is x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. So, solution is given equation of the curve is x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. By Green's theorem, we know that the area of the curve, already the theorem of the proof is proved, a equal to 1 by 2 integral x dy minus y dx, to say that is equation 1. So, we have to take an parametric equations are x equal to a cos cube theta, y equal to a sin cube theta. So, differentiate with respect to x, dx equal to a is constant, cos cube theta differentiation is 3 cos square theta and multiple of cos theta differentiation is minus sin theta and dy. So, differentiate with respect to y, dy equal to a is constant, sin cube theta differentiation is 3 sin square theta, again sin theta differentiation is cos theta d theta. Then substitute in equation 1 these values, we get a equal to 1 by 2 integral 0 to 2 pi, then x is a cos cube theta and dx is 3a cos square theta minus sin theta and y is a sin cube theta, dy equal to 3a sin square theta cos theta. So, a equal to 1 by 2 integral 0 to 2 pi. In first term is 3a square cos power 4 theta sin square theta d theta plus second term is 3a square sin power 4 theta cos square theta d theta, that equal to, within the integral, then 3a square is a common value, then 3a square by 2 integral 0 to 2 pi and within integral cos square theta sin square theta is a common value, multiple of cos square theta plus sin square theta d theta, that equal to 3a square by 2 integral 0 to 2 pi sin square theta. Then we have to write cos square theta is in the form of 1 minus sin square theta and cos square theta plus sin square theta is 1 into d theta, that equal to 3a square by 2 integral 0 to 2 pi multiple with sin square theta, that is sin square theta minus sin power 4 theta d theta, that equal to 3a square by 2. Then separate the two integrals, integral 0 to 2 pi sin square theta d theta and minus integral 0 to 2 pi sin power 4 theta d theta. We have to write sin square theta is 1 minus cos 2 theta by 2, that equal to 3a square by 2 integral 0 to 2 pi 1 minus cos 2 theta by 2 d theta minus integral 0 to 2 pi sin power 4 theta d theta. First, to find integral 0 to 2 pi 1 minus cos 2 theta by 2 d theta, that equal to 1 by 2, then separate the two integrals, 1 by 2 integral 0 to 2 pi d theta minus integral 0 to 2 pi cos 2 theta d theta, that equal to 1 by 2. First integration is theta with the limits 0 to 2 pi minus second integration is sin 2 theta by 2 with the limits 0 to 2 pi, that equal to 1 by 2 into substitute limits, then 2 pi is upper limit minus lower limit is 0 minus sin 4 pi by 2, so lower limit is minus, so minus into minus is plus, sin lower limit is 0, sin 0 by 2, that equal to 1 by 2 into 2 pi minus sin 4 pi, 6 pi and any n pi, sin n pi is always 0, that equal 0 and sin 0 is 0, that equal 1 by 2 into 2 pi equal to pi. In a second integration is integral 0 to 2 pi sin power 4 theta d theta. So, we have to solve this integration. We use the formula in equal to integral sin power n d theta equal to n minus 1 by n into I n minus 2. So, this formula is used to solve this integration. So I4 equal to integral 0 to 2 pi sine power 4 theta d theta equal to, by using this formula, n is 4. 4 minus 1 by 4, in minus 2 means I4 minus 2, that equal to 3 by 4 I2. I2 means integral 0 to 2 pi sine square theta d theta. Again using this formula, 3 by 4, n means 2. 2 minus 1 by 2, in minus 2, n is 2, so I2 minus 2, that is I0. So that equal to 3 by 4, 2 minus 1 by 2, integral 0 to 2 pi, I0 means sine power 0 theta d theta, that equal to 3 by 8, integral 0 to 2 pi, sine power 0 is 1, 1 into d theta is d theta, that equal to 3 by 8 into integral d theta is theta with the limits 0 to 2 pi. That equal to 3 by 8 into upper limit is 2 pi minus lower limit is 0, that equal to 6 pi by 8, that equal to, after cancellation, that equal to 3 pi by 4. So substitute these values. 3a square by 2 into first integration value is pi minus second integration value is 3 pi by 4, that equal to 3a square by 2 into pi by 4. So finally we get 3 pi a square by 8. Next problem is, find closed integral x square plus y square dx plus 3xy square dy, where C is the circle, x square plus y square equal to 4 in xy plane, using by Green's theorem. Solution is, to evaluate, given equation is closed integral x square plus y square dx plus 3xy square dy. By the formula of Green's theorem, closed integral m dx plus n dy equal to double integral dou n by dou x minus dou m by dou y of dx dy. So in given problem, m is x square plus y square and n is 3xy square. Now we have to find dou m by dou y equal to, so with respect to y, x square is constant, that is 0, plus y square is 2y. So dou m by dou y is 2y and dou n by dou x equal to, so 3y square is a constant, x is 1. So dou n by dou x equal to 3y square. Next we have to find limits, x limits and y limits. So in this problem, given circle equation is x square plus y square equal to 4. First we find y limits. So in this equation, y square equal to 4 minus x square. So y square equal to 4 minus x square, y equal to plus or minus root of 4 minus x square. That means y limits are minus root of 4 minus x square to root of 4 minus x square. Next we find x limits. So put y equal to 0 in the above equation. 0 equal to 4 minus x square. So 4 equal to x square equal to 4, x equal to plus or minus 2. So x limits are minus 2 to 2. X limits are minus 2 to 2. So integral m dx plus n dy equal to double integral dou n by dou x minus dou m by dou y dx dy. Substitute these values in this formula. We get closed integral m is x square plus y square dx plus n is 3xy square dy equal to integral x limits are minus 2 to 2 and y limits are minus root of 4 minus x square to plus root of 4 minus x square into dou n by dou x is 3y square minus dou m by dou y is 2y into dx dy. That equal to, first we integrate with respect to y. So that equal to integral x equal to minus 2 to 2 and 3y square. Now integrate with respect to y, that means y square integration is y cube by 3 minus 2 into y square by 2 with the limits minus root of 4 minus x square to plus root of 4 minus x square. Substitute upper limit is root of 4 minus x square, lower limit is minus root of 4 minus x square. That equal to integral x equal to minus 2 to 2 root of 4 minus x square whole cube minus then y square and root of minus x 4 minus x square whole square, this is upper limit, minus lower limit is minus root of 4 minus x square whole cube minus of root of 4 minus x square whole square dx, that equal to minus 2 to 2 with the limits. So this is 4 minus x square whole power 3 by 2 minus 4 root of 4 minus x square whole square is 4 minus x square, multiple with minus, so minus 4 plus x square, and minus of root of 4 minus x square whole cube, that is 4 minus x square whole power 3 by 2 dx, that equal to 2 integral minus 2 to 2 4 minus x square whole power 3 by 2 dx. So integrate 4 minus x square whole power 3 by 2 integration is 4 minus x square whole power 3 by 2 plus 1 by 3 by 2 plus 1 and multiple of, so differentiate with respect to x of 4 minus x square is minus 2x with the limits minus 2 to 2. So that equal to minus of 4 minus x square, numerator is 4 minus x square whole power 5 by 2 by denominator is 5 by 2 into x. So then substitute, upper limit is plus 2, lower limit is minus 2. So we get the value is 0. The next problem is evaluate by Green's theorem closed integral curve C e power minus x sin y dx plus e power minus x cos y dy, where C is a rectangle whose vertices are 0, 0, pi 0, pi by 2, 0, pi by 2. Solution is to evaluate closed integral e power minus x sin y dx plus e power minus x cos y dy. So this is in the form of closed integral m dx plus n dy. Here m equal to e power minus x sin y, n equal to e power minus x cos y. Now we find dou m by dou y equal to, in m e power minus x sin y, then differentiate with respect to y of m, e power minus x is constant, sin y differentiation is cos y. So dou m by dou y equal to e power minus x cos y, and dou n by dou x equal to minus cos y is constant, e power minus x differentiation is e power minus x into minus 1. So dou n by dou x equal to minus e power minus x cos y. Then by using Green's theorem, the statement of Green's theorem is closed integral C m dx plus n dy equal to double integral dou n by dou x minus dou m by dou y dx dy. In this problem, we have to evaluate only RHS value of Green's theorem. The given vertices are 0, 0, pi 0, pi by 2, 0, pi by 2. So now we write x limits and y limits. So x limits are 0 to pi and y limits are 0 to pi by 2. Now evaluate closed integral e power minus x sin y dx plus e power minus x cos y dy equal to, then substitute x limits are 0 to pi and y limits are 0 to pi by 2. Dou n by dou x is minus e power minus x cos y minus dou m by dou y is e power minus x cos y dx dy, that equal to, now integrate with respect to y. So integral 0 to pi, these are x limits, integral 0 to pi by 2, these are y limits. So minus 2 e power minus x cos y dx dy, that equal to, first we integrate with respect to y, integral x equal to 0 to pi, minus 2 e power minus x is constant. Now integrate cos y is sin y with the limits 0 to pi by 2 dx. So integral 0 to pi minus 2 e power minus x, then substitute upper limit is pi by 2, lower limit is 0. That is sin pi by 2 minus sin 0. Sin pi by 2 is 1, sin 0 is 0. So 1 minus 0 equal to 1. So minus 2 is a constant. That is to, we write without integral, minus 2 integral 0 to pi e power minus x into 1 dx is dx. that equal to minus 2 into e power minus x integration is e power minus x by minus 1 0 to pi. That equal to minus 2 integral 0 to pi e power minus x dx. So, minus 2 into e power minus x integration is e power minus x by minus 1 with the limits 0 to pi. That equal to minus minus plus 2 integral upper limit is pi, lower limit is 0. So, e power minus pi minus e power minus 0. E power minus 0 is 1. That equal to 2 into e power minus pi minus 1.